and the next one is electrolytic decomposition. Thermal decomposition, as the name indicates. Thermal, it means therm. Therm, it means the heat energy. If heat energy is required to carry out the decomposition process, then it is termed as thermal decomposition process. So the next, photo means light, that is sunlight. If sunlight is used to carry out the decomposition process, then it is termed as photolytic. Lytic means breakdown. So the next one, electrolytic. If electro means electricity, if electricity is used, lytic means breakdown. If electricity is used to break or to carry out the decomposition process, it is termed as electrolytic decomposition process. First of all, we will discuss decomposition reaction. As I have stated you, a reaction in which a reactant or we can say substance, a reactant is broken down into two or more than two substances. To the next, I have told you that it is opposite of combination. To the next, it is opposite of combination reaction. It means what we have discussed. Decomposition reaction means a reaction in which a reactant is broken down into two or more than two simpler substances or substances, then it is termed as decomposition reaction. It is the decomposition reaction. It is opposite of combination reaction. Let us discuss the thermal decomposition, the photolytic decomposition and electrolytic decomposition one by one. Let us discuss thermal decomposition reaction. As the name indicates, therm means heat. It means if heat energy is used to carry out the decomposition process, it is termed as thermal decomposition reaction. It means if heat energy is used to carry out decomposition process, it is termed as thermal decomposition reaction. For example, let us understand it by taking an example. For example, when calcium carbonate, CaCO3, limestone, marble, it is known as calcium carbonate. When calcium carbonate is heated, it is represented by delta. When calcium carbonate is heated, it is broken down into calcium oxide plus carbon dioxide. it means when calcium carbonate is heated, then it is broken down into calcium oxide and carbon dioxide. We see here heat energy is used, that's why it is termed as thermal. In this case, we see a reactant is broken down into two product, then it is a decomposition reaction. It means this is an example of breaking down of calcium carbonate. It is an example of thermal decomposition reaction. So the next we will discuss by taking another example. For example, when potassium chlorate is heated, in the presence of when potassium chlorate is heated, it is broken down into potassium chloride and oxygen. That means the next one, when KClO3, potassium chloride is heated, it is broken down into potassium chloride plus oxygen. There, this is also a type of thermal decomposition reaction in which let us balance it. It means when potassium chloride is heated, it produces potassium chloride and oxygen gas. We see here a single substance or the reactant is broken down into more than two products, and it is carried out in the presence of heat. Then it is termed as thermal decomposition reaction. By taking another example, for example, the third one, when ferrous sulfate FeSO4.7H2O, that is ferrous sulfate hexahydrate, which is light green in color. Light green in color. When we heat it, then first of all it removes this water of crystallization and it forms ferrous anhydrous. Anhydrous means the water is removed. It forms anhydrous ferrous sulfate, FeSO4, which is white in color. White in color. To the next, on further heating, when we heat it again, it forms Fe2O3 plus sulfur dioxide gas plus sulfur trioxide gas. It is brown in color. It is solid and it is solid. It means what we see here, we see when ferrous sulfate heptahydrate is heated, which is light green in color. It is, first of all, this some water of crystallization is removed and it becomes anhydrous ferrous sulfate. Anhydrous ferrous sulfate. To the next, on further heating, it is converted into Fe2O3 and then at the same time sulfur dioxide and sulfur trioxide gas is removed. You see, it is a type of decomposition reaction in which a single product is broken down into two or more than two products. Clear? We will take one more example of lead nitrate. When PbNO3 is heated, it forms PbO plus NO2 plus O2. What we see here in this reaction? In this reaction, what we see, the lead nitrate, first of all we will balance it. 2 PbO, it is going to be 2 PbO into NO2 To the next. What we see here? 2 Pb. Oxygen, 3 to the 6. It means how many oxygens are there? 2, 3 are 6, 6 to the 12. What we have? 2 to the 4, 6, 6, 4 to the 8, 8 to 10, 10 to 12. Let us see the reaction is balanced. 2 Pb, oxygen 3 to the 6, 6 to the 12, 2, 8, 10, 10 to the 4, 14. It means now the reaction is balanced. We have 2 Pb, oxygen 3 to the 6, 6 to the 12, 2, 8, 10, 10 to 12. That means the reaction is balanced. 4 nitrogen and we have 2 to the 4 nitrogen. Clear. What we see here, when lead nitrate is heated, it is converted into a yellow color. It is yellow in color. Lead oxide, and which gives a brown fumes of nitrogen dioxide. We see here, by the use of heat energy, that's why it is termed as thermal decomposition, and we see a reactant or substances broken down into 2 or more than 2 substances. It is a type of decomposition reaction. We have discussed the decomposition reaction. The first one, decomposition of calcium carbonate into calcium oxide and carbon dioxide. The next, we have discussed the decomposition of potassium chlorate into potassium chloride and oxygen. We have discussed the decomposition of ferrous sulfate heptahydrate into ferric oxide and sulfur dioxide and sulfur trioxide. We have discussed the decomposition of lead nitrate into lead oxide and nitrogen dioxide and oxygen. To the next, we will discuss the photolytic decomposition. As the name indicates, photo means light and lytic means decomposition. It means when sunlight is used as energy to carry out the decomposition process, it is a type of photolytic decomposition reaction. It means if a decomposition reaction is carried out in the presence of sunlight, it is termed as photolytic decomposition reaction. For example, it is used in black and white. For example, it is used in black and white photography. Clear? Let us discuss it. How we are going to use it. For example, in black and white photography, we use silver chloride. It means AgCl. When light falls over it means Hmu. When sunlight falls over it, it is broken down into Ag plus Cl. That is balanced. It means in the presence of light, the silver chloride is broken down into silver and chlorine gas. To the next, 2 AgBr In the presence of sunlight, it is broken down into silver and bromine gas. These are the example of photolytic decomposition reaction. To the next, what we see here in photolytic decomposition reaction, as the name indicates, photo means light, lytic means decomposition. If the decomposition reaction is carried out in the presence of sunlight, and is termed as photolytic decomposition. Important is that photolytic decomposition reaction is carried out in black and white photography. Black and white photography, which we used in the previous time. What we do, we use silver chloride. When sunlight falls over it, it is broken down into silver and chlorine gas. To the next one, silver bromide. In the presence of sunlight, is broken down into silver and bromine gas. Clear? Let us discuss electrolytic decomposition reaction. As the name indicates, electro means in this decomposition reaction, electricity is used. Lytic means breakdown, decomposition is the same. It means a reaction in which electricity is used to carry out decomposition process. It is termed as electrolytic decomposition. Electrolytic decomposition reaction. For example, electrolysis of water gives us hydrogen and oxygen gas. For example, H2O it produces hydrogen plus oxygen. The reaction is balanced. The hydrogen is produced at cathode and oxygen is produced at anode. Clear? Hydrogen is produced at cathode and oxygen is produced at anode. To the next, if we compare, a question is asked in board examination that what is the ratio of hydrogen to oxygen? When we compare, we see the cytometric coefficient of hydrogen is 2. It means it is produced in 2 volume. And the oxygen has cytometric coefficient 1. It is produced in 1 volume. It means the ratio of their volume, ratio of volume of hydrogen to that of oxygen is 2:1. It means the hydrogen, it is in 2 volume and the oxygen is in 1 volume. This reaction is carried out in an jar in which water is filled, having inverted tubes over the electrodes. We see that in case of cathode it has 2 volume and in case of anode it has 1 volume. It means the volume in the cathode is just double to the volume of anode. Why it is so? This is so because on electrolysis of water 2 volumes of hydrogen is produced and 1 volume of oxygen is produced. This is an example of electrolysis reaction. Let us discuss the next example. When we carried out the electrolysis of sodium chloride NaCl. It produces Na plus Cl2. But before that, we know solid sodium chloride is non-conductor. So for that, in order to increase its electrolytic conductance, what we do, we melt it. That means it is fused sodium chloride. When fused sodium chloride, when we carried out the electrolysis of fused sodium chloride, we haven't added water here. Listen to me carefully. We haven't added water here. It means it is fused sodium chloride, melted sodium chloride. When electrolysis is carried out, it will produce sodium and chlorine gas. See here, 2Na plus Cl2. We have another example. For example, when Al2O3, when we carried out the electrolysis, it produced aluminum plus oxygen gas. It means what we know. It means when we carried out the electrolysis of Al2O3, then what we see here, that when aluminum oxide is electrolyzed, then it will produce aluminum and oxygen. When fused sodium chloride is electrolyzed, it will produce sodium and chlorine gas. To the next, the previous one which we have discussed, the electrolysis of water produces hydrogen and oxygen gas. These are the example of electrolytic decomposition reaction. Clear? Let us discuss displacement reaction. Displacement reaction. What is displacement reaction? As I have already stated you, that a reaction in which a highly reactive metal will displace lower reactive metal from its salt solution. Let us see how it is, but before that we will define it. It means a reaction in which a highly reactive metal displaces lower reactive metal